Welcome to Infigyan, my dear friends. In this video, we are going to tackle up one very interesting rational equation question. It is x square over x plus 1 plus x times 5 minus x over x plus 1 whole square equal to 6 over 5 minus x. X belongs to real number. I will solve this question by two different ways. So let me write here method number 1 and I will begin with domain of the equation. X cannot be 5 and negative 1 as they are in the denominator. So I can multiply both sides with 5 minus x. Let's multiply both sides with 5 minus x. Here we can cancel these two terms. Now I will take the product. So I will be writing x square times 5 minus x over x plus 1 plus x times 5 minus x whole square over x plus 1 whole square equal to 6. Now I will take x times 5 minus x over x plus 1 common. So in bracket I will be writing x plus 5 minus x over x plus 1 and RHS would be 6. Now I will use substitution. See this term if I will call y. So here I will be writing this term only y. So this equation will become xy times x plus y equal to 6, where y is 5 minus x over x plus 1. Now you can see if I will consider xy is one root and x plus y is second root, then this is product of roots. So let me find out the sum of roots also. So one root is xy, second root is x plus y. So this is product of roots. And now I am calculating sum of roots. So this value we will calculate. Let's put both the values y and let's simplify. So I will be writing xy plus x plus y. Remember y is 5 minus x over x plus 1. Let's put over there. So I will write x times 5 minus x over x plus 1 plus x plus 5 minus x over x plus 1. Take LCM. So this will become 5x minus x square plus x square plus x plus 5 minus x divided by x plus 1. Now I will cancel plus and minus x square plus and minus x. So what is left? It would be in the numerator 5x plus 5. Now I will take 5 common. So in bracket I can write x plus 1. Denominator is also x plus 1. So I can cancel these two terms. It will give us 5. Conclusion is xy times x plus y. Product of roots was 6. Now sum of roots we calculated. It is 5. Now we can presume it is product of root, sum of root. Now frame one quadratic equation whose product of root and sum of root is 6 and 5 respectively. So let me consider that variable is t. So I can frame sum of roots, so minus 5t, product of roots 6 equal to 0. As we know the general form how to write quadratic equation from sum of roots and product of roots. Now this is quadratic in t whose roots will be, remember roots are xy and x plus y. The value of t would be xy and x plus y. So I can use factorization. I can split minus 5t as minus 2t minus 3t. Its product is 6 plus 6 equal to 0. T common, t minus 2, minus 3 common, t minus 2. So overall we are having t minus 2, t minus 3 equal to 0. So from here we can conclude t is equal to 2 and 3. Now remember what is t. T is xy and x plus y. So I will consider two systems. Once I will consider x plus y equal to 2, then I need to consider xy is equal to 3, one system. And second system would be the reverse of that. X plus y I will consider 3, so xy will be equal to 2. Let's solve both the equations, both the systems. I will write x plus y equal to 2, xy equal to 3. I will solve here. And x plus y equal to 3, xy equal to 2. Again same logic I can apply. Sum of roots, product of roots. See, this is sum of root, product of root. So let's frame one quadratic equations whose roots are x and y. Let me call variable k. So k square minus sum of roots times k. So minus 2k plus product of roots equal to 0. This quadratic we will get. And here we will be having minus 3k plus 2 equal to 0. Let's solve both the equations. So if you will see, I will calculate discriminant here in this case. B square minus 4ac. So b square is minus 2 square 4 minus 12. So this value is negative 8. Complex solutions. So we will reject this solution set. So rejected. Now let's consider second quadratic equation. I will write k equal to, remember k value will be the value of x and y. So k equal to minus b. We can do factorization also. Let me write quadratic formula. Minus b plus minus under the root. B square is 9 minus 4ac is 8 divided by 2a is 1. So 3 plus minus 1 divided by 2. 4 over 2, so 2. And 3 minus 1, it is 2 over 2, so 1. So value of k will be 2 and 1. And what is k? K is basically roots of equation whose roots are x and y. So I will write x equal to 2. See here, if x, y equal to 2, x times y, so y will be equal to 1. And if x is equal to 1, then y will be 2. So ultimate solutions for x values, x will be 1 and 2. This is method number 1 using Vieta's theorem or Vieta's method. Sum of roots, product of roots. Now let's consider the conventional method, method number 2. Let me write our quartic equation first. So equation was, if I will write the general first one, x square over x plus 1, then I will be writing simplification plus x times 5 minus x over x plus 1 whole square equal to 6 over 5 minus x. This is our method number 2. Now I can multiply both sides with x plus 1 whole square times 5 minus x. Once I will multiply, I will be having one quartic equation. So I am writing that quartic equation directly. After simplification, it will be x power 4 minus 5x cube plus 11x square minus 13x plus 6 equal to 0. Now if I will add only the coefficients, see it is 1 minus 5 plus 11 minus 13 plus 6. Is this 0? 11 plus 1 12, 12 plus 6 18, minus 5 minus 13 minus 18. Yes, it is 0. That means x equal to 1 is our first base solution. Now I will write our coefficients of the quartic equation. So it would be 1 minus 5, 11 minus 13 and 6. Leading coefficient as it is 1. Now 1 times 1, 1, minus 4. 1 times minus 4, minus 4, 7. 1 times 7, 7, minus 6. 1 times minus 6, minus 6, 0. So here we are having coefficient for cubic equation. So let me write x cube minus 4x square plus 7x minus 6 equal to 0. Now I will check using rational root theorem method. See, we can consider plus minus 1, plus minus 2, plus minus 3 and plus minus 6. Leading coefficient is plus minus 1. If you will take the ratio of constant to leading coefficient, you will get to know the eligible possible roots of the equation. So we can consider x is equal to 1. Is this true? No. 8 minus 10. So it is not true. Let me put x is equal to 2. So 8 minus 2 square is 4. 4 times 4, 16 plus 14 minus 6. Is this true? Yes. 22 minus 22. So it will be 0. So first base solution was x equal to 1. Second base solution is x equal to 2. Now I will consider x is equal to 2 and I will consider cubic coefficients first. So 1, minus 4, 7 and minus 6. 1, minus 4, 7 and minus 6, and base solution here is x2. Let me write leading coefficient 1 as it is. So 2 times 1, 2, minus 2. 2 times minus 2, minus 4, 3. 2 times 3, 6, 0. These are coefficients of quadratic equation. So I will be writing x square minus 2x plus 3 equal to 0. If you will only check discriminant b square minus 4ac value, then you will get to know about it is minus 2 square minus 4 times 1 times 3. So it is 4 minus 12. Because of this is negative, so complex solution will generate. So we will reject from this method also. So only solution by this method also, it is x is equal to 1 and 2. Both are real valued. I hope this video will be meaningful to you. Do not forget to like, share and subscribe. Bye bye till next video. Good luck and take care of yourself, friends.